In this video, we're talking about radical equations. Radical equations aren't just really cool equations. They're equations that involve a radical. And what I'm talking about with that is square root, fourth root, third root, sixth root, seventh root, 27th root, 496th root, whatever root you want. It's in there, and that's what's making it a radical equation. So let's talk about what we're going to do. We got a radical equation. We got the square root of x minus 1 is equal to x minus 7. How do we get rid of that radical to be able to work with it? Well, remember that square root has an understood 2. It's a radical with a degree of 2 there. If we were to square both sides of this equation, when you square a square root, you're just left with stuff inside of it. So you're just going to end up with x minus 1 on that left-hand side. On the right-hand side, we do end up with x minus 7 squared, which is going to take us a little bit of work to work with. So let's go ahead, let's expand that on the right-hand side. Let's keep the left-hand side the same, x minus 1. Here we're going to use FOIL, whatever method you use. You end up with x squared minus 14x plus 49. And notice what we end up with is a quadratic equation that we need to solve up. So let's get one side equal to 0. Let's go ahead, let's subtract x. Both sides, let's add 1. And so what we end up with is x squared minus 15x plus 50 is equal to 0. We can factor that up. When we factor that up, we get x minus 10 times x minus 5 is equal to 0. And so we would set both of those equal to 0 and solve them. Let's see what we get. So we would get x is equal to 10 and x is equal to 5. Now, these are possible solutions. We need to, for radical equations, go back and plug them in. We want to plug them back into the original equation. You don't want to plug them back in here because this is an equivalent equation we found. We want to use the original equation we were given and see what we get. So let me change colors on that. So let's say I want to test 10. So I'm going to do the square root 10 minus 1. I want to know if that's equal to 10 minus 7. Well, it's going to be the square root of 9 is equal to 3. Yep, 3 is going to equal 3. We're good to go. So 10 checks out. Put a little check mark there. It's cool. Let's look at the 5. Well, we plug that in. We're going to have the square root of 5 minus 1. Okay, that seems cool. We'll have 5 minus 7 on this side, right-hand side. So it's going to be the square root of 4 is equal to negative 2. Uh-oh. Got a problem there. Because the square root of 4 is going to be 2, which is not equal to type negative 2. No. So this is an extraneous solution. It's a solution to an equivalent equation, but not the original equation that we started with. And so our solution set for this one, oops, if I can draw a brace, it's just going to be 10. Let's look at another one. Here I have the square root of x minus 1 is equal to negative 5. Now when you take the square root of a number, you should never get a negative as a result. So unless, well, for square roots, that will never happen. If it's an odd root, it can happen. But for an even root, it cannot. And so this is an even root here. It's understood 2 here. Understood 2 here. And so there's nothing I can take the square root of that will give me a negative 5. So I know right off the bat, no solution. Now, if you went ahead and solved this, if you squared both sides and got x minus 1 is equal to 25, and then we subtract 25 from both sides, we get x. Well, actually, we would add 1, right? Why would we subtract 25? We would add 1 to both sides. We would get x is equal to 26. But when you test that out, you need the square root of 26 minus 1 is equal to negative 5. And that's going to be square root of 25 is equal to negative 5. Notice the solution that we got, 5, is not equal to negative 5. So the solution that we got is an extraneous solution. So this is going to have no solution. But you can skip all that, or you can do it. But if you see an even root by itself on one side equal to a negative on the other side, that's going to be no solution every time. Here we have a cubed root. So how are we going to get rid of that cube root? We're going to cube both sides. And so what we're going to end up with is 1 minus 2x is equal to 3 cubed, which is 3 times 3 times 3, which is 27. Let's subtract 1 from both sides. We'll get negative 2x is equal to 26. Divide by negative 2, divide by negative 2, and we'll get x is equal to negative 13. Let's try it out and see what we get. The cube root 1 minus 2 times negative 13. Does that equal 3? Well, it's going to be the cube root of 1 plus 26, which is going to be the cubed root of 27. And yes, 3 is equal to 3. Checks out. So we have a valid solution of negative 13. If this had been a negative 3 here, would have still been okay that we would find a solution. It may be a different solution, but we could find a solution for that in theory. And let's look at this one. So we have an x other than the x under the even root, which I believe the first example had as well. But we also have a constant out here as well. So when we square both sides, the square here on the right-hand side, square here on the right-hand side, it's going to distribute to the 3 and the x, okay? So what we end up with is x squared is equal to 9 times x. And so what I would do here is I want to get one side equal to 0. I'm going to subtract 9x from both sides. Oops, there we go. We'll get x squared minus 9x is equal to 0. And I'm going to factor an x out. I got x in this term, x in this term. Let's factor that out. X times x minus 9 is equal to 0. And so that gives me a solution of x is equal to 0 and x is equal to 9. We could test them out. Does 0 equal 3 times the square root of 0? Yes, it does. Does 9 equal 3 times the square root of 9? Does 9 equal 3 times 3? Yes, it does. So both of these are valid solutions. We got 0 and 9. And that's it for radical equations.